So guys, welcome to our channel once again. In today's video, we are going to answer these 10 repeated questions on work, energy and power. So let's start with the first question here. It says, a car traveling at 30 meters per second overcomes a frictional resistance of 100 newtons while moving. Calculate the power developed by the engine. Take 1 horsepower is equal to 0.75 kilowatts. So guys, for this here, we're going to calculate that power is actually equal to force times velocity. So here the force is 100 newton and the velocity is 30 meters per second. So when we multiply 30 by 100, we'll have 3000. So that's 3 kilowatts, guys. So if 1 horsepower is 0.75 kilowatts, then 3 kilowatts will be 3 over 0.75. So when we calculate that, we'll have 4 horsepower. And that's option D here, guys. So let's go ahead and consider the next question. Alright, so guys, the next question here, question number 2 says, a man weighing 200 newtons runs a staircase in 5 seconds. If the height of the staircase is 9 meters, calculate the power of the man. So guys, let's take that power is equal to energy over time. So here the potential energy is going to be calculated as mgh, where the acceleration due to gravity g is actually 10. Then the height also is given here to be 9 meters. That's the height of the staircase. But we don't have the mass here, but we can actually calculate for the mass, having that the man is weighing 200 newtons. And we know that weight is equal to mass times acceleration due to gravity. So in that case, if the weight is 200 newton, then the mass is the weight over the acceleration due to gravity. So that's 200 over 10, and that's 20. So the mass of the man is 20. So if we go ahead and calculate for the power using mgh over t, that will give us 20 times 10 times 9 all over 5. So let's go ahead and check this out and see what we have here. So guys, that's 360 watts, and that's option C here. So let's go ahead and consider the next question, guys. Alright, so guys, the next question here is question number 3. It says, a body of mass 2 kg is released from a point 100 meters above the ground. Calculate its kinetic energy 80 meters from the point of release. So guys, here we are going to have, since the kinetic energy is actually half mv squared, and we don't have the velocity here, and we can actually state that the kinetic energy at 80 meters from the point of release is actually equal to the potential energy at 80 meters from the ground level, and that's mgh here, guys. So that will give us that the kinetic energy is equal to the potential energy. So in this case, mgh is equal to the mass, which is the 2 kilogram, times the acceleration due to gravity, which is 10 meters per second square, then times the height, which is 80 meters. So 2 times 10, which is 20 times 80, which is 1600 joules. And that's option B here, guys. So option B is the answer to this question. Let's go ahead and consider the next question. So guys, the next question here is question number 4. It says, a ball is dropped and it hits the floor at a point A. It rebounds upwards to a point B. So while moving from A to B, its A, kinetic energy is increasing, B, potential energy is decreasing, C, potential energy is increasing, D, kinetic energy remains constant. So guys, while moving from A to B, the potential energy will be increasing. So that's it for this question, option C. So let's go ahead and consider the next question, guys. So guys, the next question, question number 5 here says, a body of mass 7.5 kg is to be pulled up along a plane which is inclined at 30 degrees to the horizontal. If the efficiency of the plane is 75%, what is the minimum force required to pull the body of the plane? Alright, so guys, the efficiency of the machine is 75%. So let's recall that efficiency is 1 over the velocity ratio times load over effort. Alright, so guys, the velocity ratio is here 1 over sine theta, and the angle theta here is 30 degrees. So 1 over sine 30 will give us 2. So in that case, the efficiency of the machine here is equal to 1 over 2 here, which is the velocity ratio. So times the load here over the effort. So guys, here the load here is actually from the mass 7.5 kg, and this mass times the acceleration due to gravity, which is 10 meter per second squared, will give us 75 newtons. So we have the load at 75 newtons here. So having load at 75 newtons, if we impute all this into the equation, we are going to have that the efficiency 75% is equal to 1 over the velocity ratio, that's 1 over 2, times the load, which is 75, over the effort, which is not given, then times 100%. So guys, this will be that 75% is equal to 1 times 75 times 100. So that is 7,500 over 2 times the effort, that's 2E. So guys, in that case, we are going to have that 75% is equal to 7,500 over 2E. So guys, we can actually cancel out here for 75 and 7,500. So we have that 1 is equal to 100 over 2E. So if we cancel out between 100 and 2, we'll have that 1 is equal to 50 over E. So in that case, E is equal to 50 newtons, and that's option C here, guys. So let's go ahead and consider the next question. So guys, the next question we have here is question number 6. It says, the total area under a force velocity graph represents A, momentum, B, power, C, energy, D, pressure. So guys, the answer to this question is option B here, power. Power is the area under a force velocity graph. And that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 7. It says, which of the following statements correctly defines quantitatively the work done by a force? We have the product of the force and the distance moved. A, parallel to the line of action of the force and reference points. B, on the line through the reference points. C, perpendicular to the line of action of the force from the reference point. And D, by the object. So guys, the answer to this question is option A, parallel to the line of action of the force and the reference points. And that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 8. It says, the vertical string suspended from a fixed point and having a small mass attached to the free end is set into oscillation. Which of the following statements about the system are correct? We have I, the potential energy of the mass is minimum at the middle of the swing. II, the kinetic energy is a maximum at the middle of the swing. III, the sum of the potential and kinetic energies is constant throughout the swing. Alright, so guys, we have option A as II, and III. Option B, II and III only. Option C, I and II only. Option D, I and II only. So guys, the answer to this question is option B here, II and II only. So the kinetic energy is maximum at the middle of the swing, and the sum of the potential and kinetic energy is constant throughout the swing. And that's it for this question, guys. Let's go ahead and consider the next question. Alright, so guys, the next question here, question number 9 says, a load of mass 120 kg is raised vertically through a height of 2 meters in 30 seconds by a machine whose efficiency is 100%. Calculate the power generated by the machine. So guys, let's recall that power is the work done over time taken. So guys, also power is equal to mgh over time. So in this case, we are going to have the mass 120 times the acceleration due to gravity, which is 10 meters per second squared, then times the height here, which is 2 meters, then over the time, which is 30 seconds. So guys, let's go ahead and plug this in and then calculate for that. We're going to have 80 watts here, and that's option D. So option D is the answer to this question, 80 watts. So let's go ahead and consider the next and last question, guys. So the last question here, question number 10 says, the engine of a train produces a force of 3000 Newton when moving at 30 meters per second. Calculate the power of the engine. So guys, let's recall that power is equal to force times velocity. So in this case, the power here is going to be the force 3000 Newton times the velocity 30 meters per second. So 3000 newtons times 30 meters per second will give us 90,000 watts, and that's 9 times 10 to the power of 4 watts. So that's option C here, guys. Option C is the answer to this question, and this is where we end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. You can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.